This is the second video in a two-part series explaining roots and radicals. In this video, we will cover cube roots and larger roots. We will also simplify radicals. Let's get started. Cube roots and larger roots. A number such that x times x times x equals c is a cube root of c. This is basically saying that a number cubed, or a number times itself 3 times, is the cube root of c. For example, -4 times -4 times -4, or -4 cubed, equals -64. Finding the cube root of a number is the reverse of cubing a number. So for example, look at the equation at the bottom. When we cube -4, we get -64. But if we take the cube root of -64, we get the reverse. Our answer would be -4. Perfect cubes. A number that is an exact cube of another number is a perfect cube. Here I have listed a few perfect cubes and their principal cube roots. Let's solve some problems. Let's find the principal cube root of the cube root of -27. To find the cube root of -27, you want to think, what number cubed would give me -27? In this problem, we know -3 cubed equals -27. So the principal cube root for the cube root of -27 is -3. Let's solve another problem. This time, let's solve a fraction. Let's find the cube root of 8 over 125. Just like in the last problem, you want to think, what number cubed would give me 8 and what number cubed would give me 125. Now, for this problem, and starting with the numerator 8, what number cubed that will give me 8 is the number 2, because 2 times 2 times 2 equals 8. And for the denominator 125, that number is 5 cubed, because 5 times 5 is 25 times 5 again is 125. So the principal cube root of the fraction 8 over 125 is 2/5. Now, let's solve for this decimal. Let's find the cube root of 0.008. Just like all the previous problems, we want to think, what number cubed will give us 0.008? And for this problem, that number is 0.2. So 0.2 cubed equals 0.008. And 0.2 is our principal cube root for this problem. Let's talk about larger roots for a minute. And by larger roots, I mean roots larger than the cube root, like 4th, 5th, or 6th root. Look at the expression, the n root of a. This expression is called a radical expression. And the letter a in this expression is called the radicand. The letter n is called the index, and it tells us which root we're using to solve the problem. Now, here is the general rule you use when you're solving larger roots. Now, I'm not going to read this general rule word for word, but I'm basically going to break down what it means. And as a general rule, when you're solving larger roots, if your radicand, remember the radicand is the number under the root sign, if that is positive, you will only have one positive principal root. Whether your index, remember the index is what root we're using, whether it's the 3rd root, 4th root, 5th root, or whatever. Whether your index is even or odd. Also, if your index is an even number and your radicand is a negative, then in that situation you will not have a principal root, and the answer is not defined, because you can't have, let's say for example, the square root of -9. There is no square root of -9 because in that situation, it's not a real number. We can't solve for that. And then finally, the nth root of 0 is 0. That's pretty self-explanatory. When we solve some problems, you'll better understand this general rule. Let's find the fourth root of 81. In order to solve this problem, we want to find a number that we can multiply times itself 4 times to get 81. For this problem, 3 to the 4th power, or 3 times 3 times 3 times 3 equals 81. So 3 is the principal root for the fourth root of 81. Let's solve another problem. Let's find the fifth root of negative 1 over 32. In order to solve this problem, we want to find a number that we can multiply times itself 5 times to get negative 1 over 32. For this problem, negative 1/2 to the 5th power equals negative 1 over 32. So, negative 1/2 is the principal root of negative 1 over 32. Notice in this problem that we have a negative number under the radical sign. We were able to solve this problem because the indicator, the number 5, is an odd number. Had the problem been to the fourth root, or the indicator been an even number, we would not have been able to solve this problem, and our answer would have been undefined or not a real number. Let's attempt to solve this problem. The sixth root of negative 1. Since the root we are trying to find is the sixth root, and that root is an even number, and the number under the radical sign is a negative number, the answer for this problem is not a real number. If we try to multiply negative 1 times itself 6 times, we would get a positive 1. Let's find the 50th root of 0. Since we have 0 under the radical sign, regardless what root you're looking for, your answer will always be 0. Let's simplify the expression, the square root of 48. Since the square root of 48 is not a perfect square expression, I'm going to write the expression as a product of two expressions, the square root of 16 and the square root of 3, because I know 16 goes into 48 3 times, and 16 is the largest perfect square expression for this problem. Now you want to find the square root of each expression. So the square root of 16 becomes 4, and the square root of 3 cannot be simplified further. So our answer for this problem is 4 times the square root of 3. Let's find the square root of the fraction 3/4. First, we want to write the square root of 3/4 as a product of two numbers, and one of those numbers will be the largest perfect square for the problem. For this problem, these numbers are the square root of 1/4 times the square root of 3. Now that we have written this problem as a product of two numbers, the square root of 1/4 and the square root of 3, we want to simplify each expression. The square root of 1 over 4 equals 1/2, and the square root of 3 cannot be simplified further. So our answer is 1/2 times the square root of 3. If you found this video helpful, like it and subscribe to the channel. Remember, algebra is simple when you start with the basics.